So we are with this second part of this trusses. So calculate the forces in all members if the cross section of each bar. So this actually we have each bar, that means vertical and horizontal. So vertical and horizontal. And because diagonal is mentioned over here, that is 1000. E we have 2 into 10 raised to 5, a pin jointed truss with two diagonals. As simple as shown in figure, the bar AB is last to added and is short by 2 millimeter. AB is short by 2 millimeter. So we have step 1, static indeterminacy. Indeterminacy. Then we have ds E equal to R minus equilibrium equations equal to 3 minus 3 0, because we have this as simple support. So two reactions we have over here and one reaction we have over here. Then dsi m minus 2j minus 3. So m we have 6 minus 2 into 4 minus 3, that is 1. So truss is internally redundant to degree 1. Then we have step 2, selection of redundant. Selection of redundant. Then we have to consider the member which is short. That member we have to consider as redundant. So member with lack of fit. With lack of fit should be considered as redundant. Should be considered as redundant. And therefore we have to consider member AB as redundant. So member AB as redundant. Then we have to go for step 3, P forces. So step 3, P forces. No external loads are acting on it. External loads are not present. Loads are not present on truss. On truss. Therefore, P forces are 0. P forces are 0. And then we will go to the K forces directly. So we will have horizontal 4, vertical 3. You can see vertical 3, horizontal 4. A we have below. So I will plot it. Sorry, we have to apply unit in AB. So we have this as 4. And vertical we have 3. So AB we have to consider 1 tensile. So external your reactions, these are 0 because we have internal redundant, and then this also we have 0. Then we have this as one member, second member A, B, then we have C and D. So this is 3 meters, 4 meters. So we will get this angle as 36.87. Now we will consider joint B. So we are with joint B. This is 1. And we are interested to find force in this member, which is FBD. Now this angle we have 36.87 and this is FBC. So we have summation FY0. So minus 1 minus FBD sine 36.87, and that is equal to 0. So from this we will get value that is 1.67, and therefore FBD equal to minus 1.67 kilonewtons. This is completion. Then we will have summation Fx0. So we have minus FBD cos 36.87 minus FBC equal to 0. Now minus FBD we have minus 1.67 cos 36.87 equal to FBC, and we will get FBC that is equal to 1.67 cos 36.87 is 1.34. So we have 1.34 positive means tensile. Then we can have force. We will now use another color, and we have force in member BC. So in BC we have 1.34. And in BD we have compression, and that is 1.67. Now B and A joint we are in the same. This is one, this is diagonal, this is this member AD, and therefore we have this again 1.67. And force in this we will get 1.34. So automatically CD will be with unit value tensile. So we are with these member forces, and now we will go with the equation from which we have to find the forces. So we have equation that is dq is equal to dql plus f into r. Now here dq we have 0, dql means deflection due to loads. Now it becomes dq lack of fit. Then K we have summation K square L upon AE, and then into R. Now we will go for summation K square L upon AE. So we have summation K square L upon AE. So we will find this. Now you can see we have for vertical and horizontal members, vertical and horizontal, we have AE equal to A we have 2000 and E we have 2 into 10 raised to 5. And this value we have this as millimeter square, and this is Newton per mm square. So we will get this value in Newton. So it goes to 4 into 10 raised to 8 newtons. And that is equal to 4 into 10 raised to 5 kilonewton. Now we will go AE for diagonals. And we have change only. Here we have 1000 into 2 into 10 raised to 5, and I can write directly 2 into 10 raised to 5 kilonewtons. And then we will use these values, and then we will find K square L. Now we have member AB and member CB same. So all we have twice. So I will take 2 outside. Then we will go first my vertical member AB. So 1. So we have 1 square. L we have for this 3, and AE we have 4 into 10 raised to 5. So you can see 4 into 10 raised to 5. Then we have second, that is horizontal member, 1.34 square into 4 divided by same value of AE, 4 into 10 raised to 5. And then plus we have diagonal, which is 1.67 square. So I'm not taking minus because we have square, so it becomes plus only. And into we have diagonal distance 3, 4. So diagonal comes 5 divided by, now here we should be careful, 2 into 10 raised to 5. And then from this we will have 9.52 into 10 raised to minus 5. And then we will substitute values in this equation. Then we will have this as 0 equal to lack of it. We have that value given, which is 2 millimeters. So we will take it as 2 into 10 raised to minus 3 plus, now we have this value 9.52 into 10 raised to minus 5 into R. And from this, so this is short, and as it is short, so we will have this value that is minus 2 into 10 raised to minus 3. And if we solve this, we will get the value of R that is equal to 21 kilometer. And now if we will find the forces in the members, then I will make that truss and I will write forces in the members. So we have these as diagonals. These are diagonals. And here we have simple support. And here we have roller support. Now in AB, we have 21 kilonewtons. So as PF P is 0, so we have PF final force is equal to P plus RK. Now this is 0, so we will get directly R into K. So now here we have 21 kilonewtons. So this is AB, and the same we have in CD also. So we have this also 21 kilonewtons. Now we have BC, so we have 1.34 into 21, 28.14. This is also tensile. So we have this as 28.14. Again, we have this as tensile. So how we will calculate it? So we have this 1.34 and we have R into K. So we have 1.34 into 21. And then we have diagonal, which is compression. And we have 1.67 into 21. So we will have this 35.07 kilonewtons. So 35.07 kilonewtons. So likewise, we have to find forces in the members when we have lack of it. For temperature change also, we are in the same fashion. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.